there are major items that engineers deal with. First of all is research. This is done more by higher qualified engineers. So if you are going to be involved in research, that is in advancing the field, you might need to advance further by probably doing a master's degree or a PhD. And therefore, this is what a master's holder and PhD holders do every day. That is advancing the field, coming up with better systems, designing better ways of solving engineering problems, etc. So that is one thing that engineers do. Then development. Most of these are always together, such that you find a division in an engineering company called R&D. When you find that, you always know that it is a branch of the company that deals with research and development. PhD holders and master students or holders, they do some research, some simulations, some field work, and they come up with what is normally called scientific papers. They might be called journals or conference proceedings. So what you find in the engineering conferences is that people are discussing different aspects of their field that they have discovered, or they are discovering, or they're researching on. So that is what is falls under the category of research. But then after research, companies now start develop the products that have been discussed or that have been published by researchers. So they go to the lab and they develop products, and before they are taken to the market, they are tested to make sure that they meet the design requirements of the industry. Therefore, that is what involves constitutes development. Most of these tasks are interrelated because in the lab, that is where most of the testings are done and confirm that the products developed are going to do the work that they should do. So what the testing does is to verify the integrity, the reliability, and the quality of the systems. And there is a huge divisions that you'll find in companies that are called QA. QA falls under the category of what is called quality assurance. So again, for those who might have heard it for the first time, quality assurance simply deals with different aspects of engineering that are pertained to testing. So they will test to verify that the product does what it should do, and it is reliable, it doesn't fail when exposed to different conditions, and it has the highest quality that has been defined by the engineering standard. So again, now the most common task that engineers do, and I think we have seen that in the past, is developing specifications for manufacturing, construction, design, or implementation. So this is what a typical engineer will do. That there's a building that needs to be built. Probably it has 20 floors. It is going to be housing some engines. It's going to be housing some heavy duty electrical components. Then we require a design engineer to come and advise the kind of electrical wiring and systems that are going to be required in that kind of a building. So that is what. So they're going to be developing specifications that must be met for the system or the product to be manufactured. So again, there is some aspect of analysis that is done in R&D that involves simulations and mathematical models. And I think I will get some videos over time to show you what kind of simulations that are done in R&D. So I will be sure to do that. Then develop systems, integrate components to produce functioning product. That is what engineering will do. So as I have shown you in our previous slide, I have shown you a motherboard, and a motherboard is a board that hosts different components. So in the motherboard, you'll find resistors, you'll find capacitors, you'll find inductors, you'll find transistors there. All of them are doing different tasks, perform one role or one or many tasks. So that kind of integration of components, it gives you a system. And again, they are also involved in manufacturing, because once now you have made this one and you have tested it, it has gone through R&D process, it has been tested and analyzed. Therefore, it requires to be manufactured. And manufacturing now involves you producing in mass, in large quantities. And again, that still falls under the category of the systems or factories that are going to be producing those products. And finally, building those components might still be under the category of manufacturing, but we still see that they are constructed different. Like substations are constructed, they are not integrated. Like we talk about integration of the small component, but again, at high level, substations, power generations in hydroelectric systems, these are constructed and they still require to follow the design requirements of engineering. So our last slide for this subsection of the lecture is that in general, engineering will do consulting, will do management, technical support, customer support, maintenance, plant operation, and sales, among others. That these are some of the things that what engineers will be doing. As I've said in the past, that ideally engineers are not meant to do electrical installations or maintenance, but nevertheless, because they are the best with the best knowledge of how systems or products should work. Then you'll find that they are always everywhere. In sales, you're going to find engineers because engineers understand the product best. In customer support, customers are asking, how does this product work? And some questions are too technical that can only be answered by an engineer. And therefore, you find engineers at customer support, which is also falls under the category of technical support. And even the plant is going to be operated and maintained by engineers. Again, you find engineers in management because there are decisions that need to be made that involves engineering knowledge, and therefore you find engineers in management making decisions about procurement, about what kind of products to be bought, among others. And lastly is consulting. Consulting now involves planning and implementing or assisting the contractors to come up to design the product. So we will, I think we'll see more of this in our subsequent lectures. In the next section, you're going to be discussing the roles of engineers in more details and the tasks that they do. So this is more of a highlight. So someone has asked what is metallurgy engineering, and I want to respond to them and say that it's a branch of material science. Material science is also a branch of mechanical engineering on a broad scale, and it deals with physical and chemical behavior of mechanical elements, their intermetallic compounds, and their mixtures. They are called alloys. And I think we have heard of alloys, we have seen them. They make better materials, particularly for different qualities. Like example that comes to mind is that wheels of vehicles are made by alloys, so that they have different properties to withstand different kinds of pressure that the vehicle might go through, be it when they are on the road. So different materials or metals are combined to form different alloys, and therefore that category of engineering is the one that is called metallurgy engineering. Someone is asking what is R&D, and I think I spent some time talking about what is R&D. I say that is a research and development aspect that is involved in any development of a product. So by Google is defining it as the process by which a company works to obtain new knowledge that it might use to create new technology, products, services, or systems that it will either use or sell. So that is what I have just described in our this lecture, that you'll find most of the companies that are well known or that are well established, they have that division called research and development, or R&D, that develops new products, new technologies, or new systems that it intends probably to develop in the future. And you can think about it. Every time we hear of phones that are developed, most of you have now camera phones. 5 years ago, we never had triple cameras. You only had one camera. And therefore, this product was under research and development. People are asking themselves, how can we develop better cameras? How can we, instead of just increasing the pixels of one camera, how can we develop better cameras so that they are probably cheaper, they are producing better quality of photos, etc. So someone went to do research. They went through different ways that different cameras can be designed, and over time they actually found out that there is a better way of developing cameras, and they came up with a triple camera. So this was produced by a work of R&D, and I think that's as an example. Someone is asking how is the employability for engineering? You can actually actually Google that question for you because it's a very good question. Employability ability for engineers, and I can tell you that there's a book I was actually reading before. I think the one I shared with you. It says that of all graduates, only about 5% or less of all the graduates in the world are engineers, and therefore the kind of systems that you see built is made only of 5% of engineers, and therefore you can guess all the technology companies like Google, like Kenya Power, Safaricom, Airtel, all those companies that require engineers. If at any one point we are producing 5% of engineers, then there are so many companies that require people. Then I can tell you that the probability for engineers. So someone is asking, can electrical engineering dive in to computer engineering since you are mother of electrical? I tell you yes, you can become a computer engineer because you have most of the skills that computer engineers require, and therefore you are best suited to electrical computer engineer. And you can always choose your career. I told you in the past that the first degree just prepares you for the work environment. It gives you a broad perspective of what life as an engineer will be. And the videos I shared with you actually talks about that. So you can become anything you want. We give you the basic skills or the very broad knowledge, but then you can become you can choose the career amongst the very many that someone says that I thought robotics is specifically under mechatronics or not mechanical engineering. What we have said is that there is no one clear line of saying what is under what. Mechanical engineering actually is the mother of mechatronic together with electrical. So it is like we have branched some concepts of, and I'm simply saying that mechanical engineering and electrical engineering. So this comes from this and this. So, and then if you have robotics, then robotics might now fall under this, all of them. So don't get confused about what falls where. There is no clear-cut line that says that robotics or mechatronics is under mechanical engineering or the other. Then someone is asking, can electrical electronics engineers dive into biomedical? Yes, I said that in the past. You can always dive into biomedical engineering. We say that biomedical actually comes from electrical engineering. Most of the times, biomedical engineering is done as a postgraduate degree or diploma, such that you have learned all the basic engineering and basic electronics and basic systems, how they are built, and therefore you become an expert of biomedical engineering. Therefore, if you want to become that, of course, you can dive into biomedical. That to respond to that question that is asking, what is the difference between aeronautical and aerospace? So what we are teaching you in the university is you can always gather information for yourself, and just like I have done Google, it will tell you the difference. In brief, we are seeing the answer there. Aeronautical deals with the flight in the Earth's atmosphere. That is, astronautical deals with the travel in space, and aerospace covers both realms. So you can see a very good definition here. So even without pretending that I know much, I just did a Google. It gives me 3 definitions: one for aeronautical, the other one for aerospace, and the other one for astronautical. So you just got some keywords. Probably I should ask this one in the exam, so that if you have attended, then you will know that we have what you have learned there. So again, Esther says that this is a very interesting class. Thank you very much. Yes, someone is asking if can someone with electrical do a project in drone, and I say yes, you can always join a project in drone. So I said in drone you can make drones. Engineering learns both the basic principles that can be required to make a drone or design one. So you can. That is actually yes. And Paul says the very interesting class. I'm very glad that you find it interesting. So that marks the end of the question and answer. All questions have been responded to.